In this short video, we will explain how the ever-increasing integration of desktop PCs, smartphones, tablets, and all the software that runs on them is not just convenient for us, the end users, but also for attackers who now have a convenient path into all of our devices. And we will see how they can use that to bypass two-factor authentication and do all sorts of other nasty things. Let us first look at how we can install apps today. This is not the attack, it just shows you the integration that makes the attack possible. We have a regular Windows installation and we start up Chrome. Then we go to Google and we go to the Google Play Store. We select an app, in this case Smart News. And we say that we want to install it. Okay. Notice that we can set all the permissions for the app. And if we press Install, we can install it on any device that we own that is associated with our Google account. In this case, our smartphone. Okay. We press OK and the app will be installed on our smartphone. Now assume that the browser that we use on our desktop is hacked, is compromised. So the attacker owns the browser. In this case, it's an Internet Explorer browser, which we hacked. Okay. The user doesn't know that. He just logs into his Google account and it uses one account for all of Google's services. In this case, we log in, it's a vulnerable browser, there's actually malicious code, a man in the browser, Okay, so we log in and we see immediately that our password has been stolen. We show this in a pop-up. Normally you wouldn't see this and we only show this for demo purposes. Moreover, as soon as we click anything on the page, we see that this token is displayed. This is a token that means that we're interacting with the Play Store. Essentially, the token is required for all these interactions, all the requests that go to the Play Store. And it means that behind the scenes, the malware, the malicious code, is interacting with the Play Store. We don't see this except for this pop-up, which we only display for demo purposes. Another indication that our malicious code is interacting with the Play Store is that we show the device ID. Again, for demo purposes. It means that the malicious code is currently installing a malicious app on our device, in this case our phone. So let's have a look at our phone. Here's our phone. And without us doing anything, we see that in the top left corner something is downloading. This is the malicious code downloading our app, and we see that it's currently installing it, and at some point it is done. Now the app still needs to be activated, but this is easy. If the icon is attractive, the user will click on it and activate it. But even if not, then you can activate the app, for instance, from the browser by replacing bookmarks, and as soon as a user uses a bookmark, the app will be activated. We think this is crazy. We basically allow a compromised browser to install any app with any permissions on any device we own. Surely Google shouldn't make it that easy. Remember, this app can do anything. Read your sensitive data, your pictures, turn on location tracking, read your SMS messages, and so on. As an example, say the attacker wants to update your PayPal app. In this case, the app looks around, sees that PayPal is installed and pops up a message saying that PayPal has to be updated. In fact, it will do a reinstall. So the user clicks reinstall and confirms that this is really what he wants, uninstalls the previous version of PayPal and then reinstalls the new version. Okay. The new version, of course, is exactly the same as the old version of PayPal. It has all sorts of permissions, but it has some additional functionality. It's a so-called repackaged version of PayPal. The PayPal version that we install will actually steal the credentials of the user. Here we see an example. When we start the PayPal application that the attacker has now installed instead of the old PayPal application, we can still do anything we want. If we log in to our PayPal application with some arbitrary username and password, in this case password is secret, for demo purposes the malicious code will display the password. And there it is. The attacker now is in possession of your PayPal password. Finally, we show that the attacker is totally, utterly in control of your phone and in fact can get a shell, which means that he can log onto your phone, look at all the files, steal them, look at your download history, look at your browser history, do anything an attacker might want to do. In this case, the malicious app connects to a simple malicious web server, which we see here on the left. And we see that there is now a connection, and on the right we see the shell, that is the command line. In other words, we see the attacker being active on our phone, listing all the files that it finds there. Okay, going to the SD card, having a look at maybe our browsing history, our downloads history, maybe some sensitive files that he or she may see there, download them, anything the attacker wants. Here we actually see some of these interesting files, like admission letters or a copy of the owner's passport. There could be all sorts of things on this phone: pictures, sensitive private data, location data, and so on. We emphasize again that this attack was made possible by the relentless push toward seamless integration, or thoughtless integration, as we should probably call it, by companies like Google, who want to make everything easier. Google's not the only one. Our intentions are good, and we hope that Google will fix this bug. In general, we like Android. We just think that security should come first and not as an afterthought.